Naren Vyavahare. I'm a Hunter Endowed Chair and Professor of Bioengineering at Clemson for last 22 years, and I'm also a CSO for Annoviant Healthcare. So Annoviant is developing breakthrough medical devices that can be used in pediatric patients. Those are with the congenital heart disease. So we are trying to develop device that can grow with patient and it will not cause thrombosis or any other issues with the device. Currently, there are devices that are made up of tissues. These are animal tissues coming from bovine or cows or pigs, but they are fixed in a chemical called glutaraldehyde. So once they are fixed, they do not degrade. So they stay in your body for forever. Baby will grow rapidly, and then this device need to be replaced every year, maybe 2 years. And they also, because babies are so active, metabolism, it can damage, degrade the tissue, cause calcification of tissues. So we are trying to develop a tissue that is biocompatible. Every year, if you have to go through a surgery for a baby, it's very traumatic for patients as well as their families. And sometimes surgeries don't go very well. So if you can prevent surgeries, you can prevent all the trauma as well as you can prevent healthcare costs too. Trying to develop a kind of a chemically way to prevent calcification. But then when we start talking to pediatric patients, pediatric surgeons, they say, these devices are not good for patients. I mean, what the problem right now is that, pediatric market is so small that big companies don't get into it. So what they're doing is they're using the adult devices in the pediatric patients. Nobody is developing specific something for pediatrics. So that's where we realize that, we need to develop something that can actually help patients. Even though there's a small population, we can hopefully get something that that's good for the baby. John Meyer, who is a very well-known cardiothoracic pediatric surgeon, and we had a grant together for for adult patients, and he was telling me, I think if you can develop something for small babies pediatric, it will be a better thing to do. So I think that's where I started thinking about, is there anything that we can develop? And we already had some technology that can be used. So we said, okay, maybe we can try with him. So I sent him some samples. He actually implanted in sheep and it looked good. I define innovation is that you try to find new ways to solve any problems. First you find out what are the problems. You always talk to end users. In our case, it's in clinicians, right? Clinicians always tell you, okay, this doesn't work. This is the problem we have. Then you try to find out what is out there and why it's not working, and try to find different ways that with your knowledge can it be done better. It's a very long process in the medical device field. It takes from the beginning, from the bench to understanding something and take it forward. It takes many years, maybe 5 to 10 years to really take it forward. It's very slow process. I think patience is what research is all about. And research, every time research does not work. Research is always, it's called research. So you constantly researching it, and sometimes you get lucky and you get something good. But I think I learned from there's a nice saying from Edison. Edison said, "I learned 10,000 ways how it does not work. I did not fail." So that's how we do it. We every time do it and just say, okay. I had to tell my students too that maybe it doesn't work. That doesn't mean that we have found out this doesn't work. Now we can go this way. And try to find ways to, maybe one way you'll find it works. Some of the problems are not solved for 5,000 years. If you see mummies when they do X-rays of mummies, they have heart valve calcification, they have calcification in the arteries, and we still have the same problem in patients today. And 5,000 years later, we don't have any solutions. So if we can come up with something that improve for the life of a patient, or general increase the age of living, that's where my passion is. I should try to develop therapies that can repair tissues by themselves and hopefully low suffering, and maybe we can live longer, healthier. I would say for all the researchers that try to find your own passion. Once you have passion, you get excited about something, you get up without alarm and you want to go and do something. That's what I'm doing for last 20 years. I think try to find something that can make a difference. And if you find something that you like, then you will enjoy most of your work, and it becomes your passion too. So that's what I tell my students that if you're excited, then you will come to the lab. I don't want you to push you to come. If you're not inside, it's not there. You have to develop inside passion for something. Not only medical research, it can be anything else. But I think first you have to have passion inside. I always consider myself is not expert in everything. I know that my areas I'm good, but there's so many other things I do not understand. I'm ready to get help wherever needed. So I think everybody should look for, nobody is expert in it. The whole field is so diverse that you need to have a lot of different partners to understand. You need clinicians, they will understand the end product, and you also need a business entities, and they can understand how to take it forward. So I think you need multiple kind of people as a team to work together. So, for me it was a lucky because I'm working in this field for many 20-25 years, multiple papers, so I knew people. So that's why I could connect people very quickly. The advice I have as an academician that you need partners. I mean, you cannot do business side of it. You need to have a lot of different collaborators and partners in the area that we don't know. But if you can develop a good team, that actually can be a central part of it, and it's fun actually seeing something not only in the lab, but that going from lab to server, actually commercial product. It's a very good journey to look at whole thing, how it happens. We have about 4 products in pipeline. So first product we are doing is a conduit. It's a small tissue-based tube with a valve inside. So many pediatric patients are born without a pulmonary valve, or they have a kind of attrition in the pulmonary valve. So they put this conduit there to suture it, and hopefully it will grow with patient and it will stay there. But we have other patches, sometimes you have a hole that you want to cover the hole with the patch. So we got another grant for patch. It's kind of a square patch that they can cut to the size and suture it, and that patch will also grow with patient. We are also making a heart valve that can be implanted with the percutaneous. Instead of opening your chest, now they can do percu. That means percutaneous. So they put a valve on a stent, and they put through your groin, and it goes all the way to your heart. It's a non-invasive surgery, minimally invasive surgery. That can so a lot of research is going on in that. So I think we have a product that we are working with Georgia Tech right now to develop a stent delivery system for our product. My name is Naren Vyavahare, and those were my notes on innovation.